some more trigonometry. Now we're told to work out the value of sine 105 and cos 105 without a calculator. Okay, now this without a calculator means I should not see any non-terminating decimals. Your final answer should have roots, so maybe a root 3 or a root 5, or surds, that's what I mean. So it should be in surd form, because sine 105 and cos 105 are not exact values. Now when you're asked to do something like this without a calculator, what should come to your mind is you should be able to write or rewrite these angles in terms of the special angles. Now special angles are are those 0, 30, 45, 60, 90, 180, 270, 360. Those are special angles, and those ones 60, 30, 45, you should know what their sine, cos and tan values are. Okay, you don't need a calculator, they are special. Okay, so you should know them. Now this 105, you can write it, you can rewrite it the easiest way, or find a combination of two special angles that you can write it as, and the two special angles are 60 and 45. 60 plus 45 is equals to 105. 60 is a special angle, 45 is a special angle. So notice I'm not rewriting 105 as 100 plus 5. That is true. 105 is equal to 100 plus 5, but neither of those angles is special. Okay, so it doesn't help me much. And I'm not rewriting it as 90 plus 15. Yes, 90 is a special angle, but 15 is not, so I won't be able to work with that one. There are other identities, like half angle identities, that you can use for 15, but we haven't done those ones. So for now, you just have to use the special angles that we know. So here, just note 105 is equals to 60 plus 45. Okay, and both of those are special angles. Okay, so I'll start with sine. So sine of 105, this is the same as 60 plus 45. Okay, and I hope you remember your sum and difference identities. For sine, we say this is just sine of the first one, which is 60, cos of the second one, which is 45, and plus sine, think of sum, plus, okay? And then it is sine of the second one, cos of the first one. That is the formula for sum identity for sine. So it's sine of the first one, cos of the second one, sine of the second one, cos of the first one. So you just remember that. And then these values, you need to get them from your special triangles. So I'll draw the triangles over here. So the first triangle I have, there is 30 over here. Now the only thing you need to remember with these triangles is that sine of 30 is half, and sine is opposite over the hypotenuse. So opposite over hypotenuse should make half. So it's 1 over 2. This side I have 3, and then I put it under square root. So if this is 30, this is 60 over there. Okay, so I draw my triangle. I put 30 somewhere. It doesn't matter whether I put it there or there. Exactly the same, as long as I remember that sine of 30 is equal to half. So it should be opposite over the hypotenuse to make half. So it's 1 over 2 makes half. The other side I put 3 under a square root, and I'm done. And then 45 is an isosceles triangle. So this is 45, that is also 45. So this sides should be equal, 1, 1. Here I have 2, I put it under the square root. So notice the last number I write or fill in my triangle is always under square root. Here I put 1 and 1 and 2, 3 under square root, 1 and 1, 2 under square root. That's it. And these are the only two triangles that I need. Okay, so I'm gonna continue here. So sine of 60, I go to my triangle. Sine is the opposite over the hypotenuse, which is square root of 3 over 2. So that's sine of 60. Then cos of 45, I'm in this triangle. Cos is, if I'm using this 45, cos is the adjacent over the hypotenuse. So it's 1 over square root of 2. Now remember, 1 over square root of 2 is exactly equal to square root of 2 over 2 with a rational denominator. And this question says we must leave our answer with a rational denominator. Okay, so we'll do that at the end and see what we get. And then sine of 45, I'm in this triangle. Sine is, if my 45 is here, it is the opposite over the hypotenuse, so it's 1 over square root of 2. And then cos of 60, I'm in this triangle, so 60 is here. Cos is the adjacent over the hypotenuse, so this is what I have. Okay, so we know how to work out surds. We can just use our usual method, multiply out the numerator and denominators, and if my fractions have the same denominator, I can combine them. So here I have square root of 3 times 1 is square root of 3, 2 times root 2, this is just 2 root 2, and then I have 1 times 1, this is 1, root 2 times 2, this is 2 root 2. When I combine this, this is root 3 plus 1 over 2 root 2. Okay, now remember, I've been told to leave this with a rational denominator. So my denominator here is definitely not rational, so I need to rationalize it. I can multiply by root 2 over root 2. Root 2 over root 2 is 1, so when I multiply anything by 1, it doesn't change. So this is equals to square root of 3 plus 1 over 2 root 2 times root 2 over root 2. Okay, some of you may be wondering, why am I not making this negative? Okay, even if I make it negative, there's a negative 1 here and a negative 1, they cancel each other out to give me positive 1. And this 2 here, I don't need to, I can multiply it there, but it doesn't do anything because it can cancel out with the 1 in the denominator. Okay, so remember, this root 2 should multiply everything in that numerator, not just the first one or the last one. So it is root 2 times root 3, which is square root of 6. If you have two square roots multiplying, the numbers multiply each other under one square root. That's why I have 6. And then I have root 2. And then in the denominator, I have 2 times root 2 times root 2. Remember what I said? You have two square roots multiplying each other. The terms go together under one square root and multiply each other. So I have square root of 4, which is 2. So this is 2 times 2. Okay, and then when I work this out, this is square root of 6 plus square root of 2 over 4. Okay, so there are some very advanced high-tech calculators that can work this out. You just type in sine of 105 and then it'll give you this right away, but that's not what we want to see. We need to see all this procedure done. Okay, so we then move on to cos 105 degrees. Okay, now remember cos 105, we have to rewrite it as cos of 60 plus 45. Okay, then here I need to remember the formula. Cos is different from sine because it's cos of the first one, cos of the second one, minus, because it's plus, the opposite over there, sine of the first one, sine of the second one. So this is just cos 60 cos 45 minus sine 60 sine 45. So it's cos of the first one, cos of the second one, and these signs are opposite. Okay, and then sine 60 sine 45. Now these values, I hope you still have your triangle, you can just refer to it. Cos of 60 is a half. Cos of 45, I'm going to rewrite it as square root of 2 over 2. Remember, 1 over square root of 2 and square root of 2 over 2 are exactly the same. I explained that in the previous question. And then here, minus sine of 60, this is square root of 3 over 2. And then cos of 45, this is square root of 2 over 2. Now the only reason I'm rewriting it like this or from this step is because the denominators are rational, and I don't want to have to rationalize like I did in the previous one. So I'm just making my work easier right from the get-go. Okay, so I multiply the numerators out. So I have root 2 over 4 minus square root of 6 over 4. So remember here, two square roots multiplying, the numbers under the square roots multiply each other. So it's 3 times 2, which is 6, and then they're under 1 square root. Okay, so here the denominators are the same, so I can combine these two. This is square root of 2 minus square root of 6 over 4. So again, you might have one of those high-tech special calculators. You can check cos of 105 is indeed equal to that. Okay.